When you have two lines, that makes a system of equations because it has two variables and two equations. And when we have those two lines, what we're going to look at today are the three different possibilities for a system of linear equations. Every one that we've done so far has been an independent system. So independent system is two non-parallel lines, and they will always intersect at one point. So here's an example, and we learned with independent systems that there were three ways that you could solve it. You could either graph them, and if you graph them, you could find the point of intersection. You could use the substitution technique, or you could use the elimination technique. Probably if I saw this equation, I would use the elimination technique because things are already all lined up, and I look and with my y's, they have the same coefficient of 1, but one is positive and one is negative. So if I added these equations, I'd get x plus 2x would be 3x. The negative y plus y would be 0. Negative 2 plus negative 4 would be negative 6. And 0 plus 0 would still be 0. And then in this equation, I could get my x by itself, add 6 to the other side, and divide. I get x equals 2. And then you can solve for y by plugging in either into your first equation or your second equation, the x. So if I use the equation 1 and I plug in the x, I would get 2 minus y minus 2 equals 0. 2 minus 2 is 0, so I would get negative y equals 0. So y is equal to 0. And this point, where they intersect, would have been at 2, 0. So most of the first part of this unit, or the majority of this unit, is dealing with independent systems. But sometimes you could have other systems. And the second system that we're going to look at is what happens when you have a dependent system. In other words, they're the exact same line. Two lines that are the exact same line, at how many points do they intersect? At an infinite amount of points, because they're always intersecting. Every single point on the first line is also a point on the second line. Now, in a dependent system, there is a couple of ways that you can tell that you get a dependent system. For example, if you show that these equations are the same, then you'll know it's a dependent system. One way that you could do that is if you use the graphing method, you would have to change these to y equals mx plus b. So equation 1, that one's really easy to get the y by itself because I could just add the y to the other side and I would get y equals x minus 2. Equation 2, I could get the y on the other side by adding 2y to both sides. And then to get the y by itself, I'd have to divide everything by 2. 2 divided by 2 is just 1. Negative 4 divided by 2. And we would notice that they're the same. But I would guess that for most of you, the graphing method is the last method you choose, right? Because it only works sometimes and it's a little bit more work. You're probably going to get into the mode where you use substitution or elimination more often. So in this question, if I was solving it with substitution, how do we know that it makes a dependent system when we try that way? Well, you'll get a dependent system if you try to solve and everything goes away and you get something that's always true. So I'm going to show you what that looks like. I'm going to use substitution. If I use substitution, do you see how I got equation 1 by itself, y equals x minus 2? I can substitute. We have to be really careful in substitution. We're going to substitute our result in equation 1 into equation 2. So then my equation 2 is 2x minus 2. And instead of y, I can write x minus 2 minus 4 equals 0. So I substitute equation 1, I got the y by itself. Where the y was in equation 2, I substituted that in. And we get the following. So I'd have 2x, I'm going to distribute this. This will be minus 2x, minus 2 times, it'll be plus 4, minus 4 equals 0. And I get, everything cancels out. And I get 0 equals 0. Last time I checked, 0 equals to 0 is always true. Last time I checked. And if you get something that's always true, it wouldn't matter what the x is and what the y is, it will be true. So this means you have a dependent system, which means that there is an infinite number of solutions. So if you were doing your substitution method and you got 0 equals 0, it's always true, and you could say, therefore, I'm going to put a star beside this. The substitution method only works if you solve for y, and whatever you get, you have to substitute that into the other equation. Sometimes students make the mistake. They do substitution, they get y by itself, and they substitute it back into the same equation. If you substitute it back into the same equation, does it make sense that you will get 0 equals 0? Because you used the same equation twice, it should be the same answer. So it's very important that when we substitute, we have to substitute into the other equation. If it's an independent system, then you'll get your one answer. So whenever you get infinite solutions as an answer, if you use substitution, I just say do a double check to make sure you substitute it into the other equation. Because if you accidentally substitute it into the same equation, you will get an infinite solution every single time. And the last system that we're going to look at is an inconsistent system. This is when you have two parallel lines that are not the same line. And two parallel lines, they will never intersect. Right? Because if they're exactly the same, they'll never cross each other. So if you were graphing this, you would notice in graphing you had the same slope, because the same slope would make them parallel, but you would have a different y-intercept. And then you would say there is no solution. But you can also see there's no solution if you use substitution or elimination. And the way that it works, and this one looks like, oh, it's so close to being set up to use elimination. You see, you could subtract. I personally, I'm going to call this equation 1 and equation 2. I'm going to take equation 2 and multiply it by negative 1. Then my equation 1 is still x minus y minus 2 equals 0. And equation 2, if I multiply by negative 1, is now negative x plus y minus 2 equals 0. And now in front of my x's, I have the same coefficient, but one is positive and one is negative. I can add things together. And x plus negative x is 0. And negative y plus y, well, that also eliminated is 0. And negative 2 plus negative 2 is a negative 4 equals 0. So I get the following. Negative 4 is equal to 0. That is never true. So if you use substitution or elimination and your x's and your y's go away, and you get something that is not true whatsoever, this is telling you you have an inconsistent system. This is telling you that there is no solution. So these are important to look at because up till now, we've only dealt with system 1, where it's independent, the two lines intersect at one point. But we could run into situations that the lines are the same line or the lines are parallel, and then you would get, like, if you got -4 equals 0 and you were doing your work before today, you would have just been like, this is weird, I don't know what to do, I'm stuck, something went wrong. Okay? Now we know that that makes an inconsistent system. So, I'm looking at the first one. Ooh. What method do you want to use? Substitution or elimination? And Jordan, you're going to pick someone to pick. Who are you going to pick? Danny. Do you want to use substitution or elimination? Elimination. So if I was using elimination here, none of my coefficients are the same right now. Does it? I think it makes sense to take equation 1 and multiply it by 2. If I take that equation 1 and multiply it by 2, my new equation 1 is going to be 2x plus 2y equals -4. And equation 2 stays the same, is still -2x minus 2y equals 4. Add things together. 0, plus these ones eliminate as well. -4 plus 4 equals 0. What kind of system is this? And we have to write that there are infinite solutions. All right, Dan, you gonna pick the next volunteer? Jordan, you want to use elimination or substitution? Substitution. So if I was using substitution here, do you see that this is the easiest variable to get by itself? So I would take that y, I'd have to subtract 3x to the other side. That would get it by itself. That's in my equation 1. I have to substitute into equation 2. So my equation 2 I now rewrite, but instead of the y, I substitute in -3x minus 1. Now we just use our grade 9 skills. I'm going to distribute here.
Where did you get that from?
Where did I get what from?
Why?
The purple part?
Yeah.
So if I want to get this y by itself, this 3x is on the same side. What would I have to do to this 3x to move it to the other side? I have to do the opposite, which is subtract 3x on both sides. That would get my y by itself. Now what do I have on the right side? I'm going to have that minus 3x, and I still have the minus. Continue distributing. -2 times -1 is +2 equals 12. My 6x's go away, and I end up with 2 equal to 12. What kind of system is this? Inconsistent. And that tells us there is no solution, because 2 is never equal to 12. So we got an equation, and we want an equation that there's going to be no solution to. This means be parallel, but not have the same y-intercept. So they have to have a different y-intercept. So one way that you could come up with an inconsistent system is you could take equation 1 here. I could get y by itself by adding the 2x on the other side, and I could say in my equation 1, in y equals mx plus b form, I know the slope is 2 and the y-intercept is 4. So if I want another equation, my equation could be y equals, it has to be parallel, so it also has to have y equals 2x. And then I just have to have a y-intercept that's different than 4. This is your chance to use like a favorite number. Oh, I love using 37. Or you could use 22. Anything but 4 will work. Does that make sense? Okay? That's one way that you could come up with your second equation. Or, some people like to do this. Here's my first equation, right? If I have an inconsistent system, your x's would have to cancel. So let's make that 2x. So if I added with the elimination, they would cancel. Let's make this minus y. So if I added, they would cancel. Can you see that if you add this one, you're going to get 0 plus 0? If it's inconsistent, on this side we want not 0. What's the only number I can't put here? I can't put a negative 4. Anything else? 113. Perfectly fine. Because if I add it, 0 equals 117. That doesn't seem quite true. And that would make it an inconsistent system.
Why can't you put a negative 4?
Negative 4 would make it 0 equals 0. And that would be that they're parallel and exactly the same line, which would make a dependent system and not. If they ask you to make an independent system, it's pretty hard to get it wrong. In other words, if you just randomly write an equation of a line, you're almost guaranteed to get it right. Because an independent system means that you have to have two lines that aren't parallel and aren't the same. So as long as your lines aren't parallel, so here's my, right? The 2 is in front of the x. So what would be a number in front of the x that would make it not parallel? Any number other than 2. 3x plus anything. As long as your slope is different. As long as your slope is different, you're going to be fine. So here's how, if you wanted an independent system, look at your original equation, and then chances are this would be different. There we go. What is the likelihood that I would have made that my original equation? Probably very, very unlikely. That is a crazy slope. 3,285 over 1,172. As long as my slope is different, I'm going to have an independent system where it crosses at only one point. So this is, I probably wouldn't ask this question on a test because it's almost too easy to get it right. And sometimes even if you try to get it wrong, you'd make a mistake and still get it right. So you would like that. Like, as long as you did something, you'd probably get full marks on a question like that. Okay, we'll stop the video there for a different